In this video, you'll learn how to use PASCO's wireless melting point apparatus combined with the optional eyepiece camera to determine the melting point range of an aspirin tablet. Let's get started. This is a 325 milligram commercial aspirin tablet. I know this tablet is made mostly of acetyl salicylic acid, or ASA, which melts at 135 degrees Celsius. But I also know the large amount of inactive ingredients are impurities that will reduce the tablet's melting point below that of pure ASA. I'm going to use the wireless melting point apparatus to determine the melting point range of this aspirin tablet to get an idea of its purity. I've ground a tablet into a fine powder and packed at least 3 melting point determination tubes to about 3 millimeters height. I'll need at least 3 runs. The purpose of the first run is to roughly determine the temperature at which the aspirin sample first begins to melt, as well as the temperature where melting is complete. Then the remaining runs will be performed in a more slow and controlled manner for better accuracy. The goal is to have 2 runs that agree within 1/2 degree of one another, so it's possible that more than 3 runs will be required. The melting point apparatus comes with an ordinary eyepiece and a camera adapter. So if you purchase the camera, you can use the thumb screws to attach the adapter to the camera and then replace the eyepiece with the adapter. Make sure the USB camera is plugged into your device before you open the software. Then turn on the melting point apparatus and connect it in your software. I'm using Capstone software, but you can use any PASCO software product that supports both the melting point apparatus and the eyepiece camera. Visit PASCO.com to see if your device and software supports the apparatus and camera. When I connect the apparatus and collapse the hardware setup menu, I can see the determining a melting point quick start experiment. Open it. The camera feed shows up right away, but you'll need to adjust the camera position manually to get the best orientation and focus. If you're not familiar with how to work with the melting profile steps, pause this video and take a second to review the steps in the wireless melting point apparatus Get Started video. Then join me from here. My first run will use only ramp set to the maximum temperature of 350 degrees Celsius, so I can estimate the approximate temperature where melting begins and ends. Then in subsequent runs, I can return to the default template and develop a refined melting profile around my observations. Here you can see aspirin as a template choice, but that template works best for pure ASA samples. You might want to use it when you synthesize your own ASA. Now I would hit record to begin the first run, but to save time, I'll share a file with aspirin data I already collected. Here is the temperature data for the ramp-only run, and you can see I stopped recording data within 10 minutes because I had already observed melting from beginning to end. Then I set up my melting profile around the observations made in the first run. It looked to me like melting started around 133 degrees Celsius and ended somewhere around 144 degrees Celsius, so I set quick ramp to warm up the unit to 131 degrees with a short hold, and I did not add start image capture to my profile until it mattered right before ramp kicks in. I set the interval to the fastest rate, 5, that means 1 snapshot every 5 seconds. For ramp, I stuck with a 1 degree per minute heating rate to exceed the end of melting. Then I added stop image capture at the end of the melting profile. Everything you see here on the screen was in this exact state at the end of the run, which took just over 23 minutes. So let's go over how to analyze the captured image sequence once a run has ended. Switch from recording mode to playback mode to enable the playback controls. It looks like no images were captured, and that was true for the first part of the run because we didn't start capturing images until after hold. First, I got my prompt, I had to hit OK, and then we started the image capture. So advance the playback slider until you start to see images. There. And notice how the temperature reading is in sync with the images. Now, find where melting first starts. And be careful, you want to look for the presence of liquid. Don't misinterpret shifting or glistening for melting. There, right here I can see a distinct change in the character of the sample. I can see liquid in the sample on the sides, and it's also reflecting light differently. It's becoming more transparent. So melting began, well, let's round that temperature to the nearest tenth, 131.3 degrees Celsius. And next, I need to look for the sample to be completely melted and transparent. Let's see, and that's, okay. Let's see, right about there, I'd say that occurs around 136.7 degrees Celsius. So you might have noticed I was nudging time and temperature, but sometimes the images didn't change. And keep in mind, the image capture rate is set at 5 seconds, so you need to advance 5 seconds before the image changes. It's best to use the temperature associated with the first appearance of an image in the playback timeline. So we've determined the melting point range for the aspirin tablet is 131.3 to 136.7 degrees Celsius. But we need to complete at least one more run to see if the data agrees within 0.5 degrees Celsius of your previous run. So you'll need to switch back to record mode. And the camera preview will return when you click the preview button. The software remembers your profile settings, so if you're happy with them, use them again and move on, or adjust them as needed. I recommend saving the file between runs because depending on how much space your device has to spare, you might want to adjust the image capture rate to take fewer images and keep file size in check. Image files take up a lot more space than sensor data alone. Remember to run the cool function to cool the apparatus until its temperature reaches at least 20 degrees Celsius below the expected initial melting temperature. To see the complete lab investigation instructions, visit PASCO.com and search for the lab titled Melting Point of Aspirin. Adapt the instructions to test the melting point range and assess the purity of your lab synthesized aspirin. Or spice up the lab by looking for patterns in melting point range between different amounts of inactive ingredients or ASA content per tablet. Good luck on your lab, and see you next time!